Hi everyone. A couple weeks ago, we ended up dropping our waffle maker, and in the process of doing so, the little knob that controls the temperature also decided to break off. And because it has all these little tiny pins that sort of kept it in place, those things are things that actually broke off. Unfortunately, we're not going to be able to fix it by just sort of snapping it back in place. So instead, we're going to use this as an opportunity to be able to redesign a new part and hopefully show you guys how I go through the design process. This is actually a really nice project to start on because it's actually a relatively simple design. There's really not too much to it. There's a few sort of major constraints that we'll talk about and consider, but for the most part, it should be pretty straightforward. So let's go ahead and get into our design process and see what we need to do. Okay, so as usual, starting off with our design process, we want to make sure that we understand what our main objectives are. In this case, there's only really one objective, which is to replace the temperature knob of our waffle maker. So we are going to replace this waffle knob. Hopefully I spelled waffle correctly, not quite sure. Now that we understand what our objectives are, we can start to define the constraints that we're working within. So again, because this is a relatively simple design and simple project, there's not going to actually be too many things that we need to worry about. For the most part, what we can do, we can mostly sort of eyeball the majority of our design, right? So the two things I would say that we'll probably try to keep relatively sort of like tight in terms of the constraints are going to be the overall dimension of our waffle knob, just so that, again, it sort of fits nicely in there, right? And sort of like it's able to dial in whatever that temperature is. The other constraint that we want to probably deal with, or is going to be probably the most critical, or the one that we're going to need the most refinement, is actually the geometry and dimension of this potentiometer, right? Because it has a little bit of a key to keep the knob from rotating in of itself, we're going to have to make sure that we get the dimensions of that done properly. Otherwise, it'll probably just sort of like swing around on us and sort of defeat the purpose of being able to determine what temperature that thing is. So let's look at the constraints that we have. First one is probably just going to be the overall size of the knob. The other thing that we want to look at is the dimensions slash geometry of the potentiometer. And then one other thing that's, well, actually it'll be slightly related, but there's this little flange on the knob that fits into the slot that sort of prevents it from turning too far over to the right or too far over to the left. That's actually in relationship to the rotation of this potentiometer. Again, you can see the key. So that's one of the things that we'll actually have to come back to and try to figure out. So for now, the constraint that I'm just going to place in there, we're just going to say sort of rotation. Let's just call it a rotation flange, right? Rotation flange. And that should be the majority of the constraints that we need to worry about for now. So let's go ahead and sketch out our overall design and see what we have, what we're working with. All right, so we're gonna go ahead and sketch out our overall design just so that we have a pretty good idea of what we're trying to do instead of just sort of like going straight into it. So for the most part, what we're probably gonna do, again, we're gonna look at the overall base. We have our little pointer and then the geometry for how it fits into the key, right? So we'll start with our overall sort of base. Let's go ahead and label that our base. We have a little bit of a pointer, which for the most part, we're not gonna care too much about other than just kind of getting something that looks nice, but it is part of our design. So Let's go ahead and label that the pointer. The key thing that we're going to have to worry about is, like I said before, the geometry for how the the knob actually fits into the potentiometer. So that's going to be the most important part, the geometry for that. So let's call this the key. I think that's the proper terminology for that. We're going to call that a key, right? One thing to keep in mind, I know we're not designing this to be a replica of this piece, right? We could, if we really wanted to, sort of redesign this so that it's exactly the same piece. But for what we're trying to do, it doesn't really make sense. This part is a lot more complicated than it has to be. But so we're just going to 3D print this, and the way that we're going to do it is essentially building off this main base, right? Incorporating this key so that it just sort of plugs in and we're kind of done. Because we're 3D printing this thing, it doesn't actually make a lot or a ton of difference whether or not we decide to sort of like fill this in. And for the most part, I think actually we'll probably fill this in to make our lives way easier. But because I want to try to make this a little bit more sort of like interesting, or give a little bit more sort of like or detail, what I'm actually going to do is decide that I want to actually add these ribs in there instead, right? I'm going to add these ribs in there. So we'll call these ribs. Hopefully, like I said, I'm not quite sure how everything is going to hold up against the heat of the waffle maker. We'll most likely, we're definitely going to go back and sort of thicken all of these walls, right? Probably about 1/16 of an inch, maybe a little bit thicker. We'll see how the geometry sort of works. If we have to, we'll probably come back and thicken everything as well. For those of you guys who have worked with me for a long time, you know that my go-to tool is typically Rhino. Part of the reason why I'm actually doing this project is because I'm starting to teach myself Fusion 360. And I think this will be actually a really nice project to work on, because there's actually a number of really small sort of design features that would probably make sense to want to set up parametrically, especially sort of like this key area, right? I'm pretty sure I might have to redesign this a couple times or print this a couple times just to get a really nice fit in there. I have a pretty good idea of what will work, but who knows? So doing that the first time will probably be helpful, or being able to do that a couple times will probably be really helpful to figure out what we're going to do. So that's our overall design. There's one last little thing that I'm going to add, all right? But that's going to be a little bit of a surprise. I'll show you guys that when we sort of do the CAD part. But that's our overall design. Our next little bit will be to get the specific dimensions that we have to work on, but that's our overall design for now. Okay, so now that we have the overall design of our project, we can start to worry about the dimensions that we want to make sure that we incorporate. The first and foremost that we want to deal with is probably going to be the size of our overall knob here. Again, it doesn't have to be that specific because we're just sort of eyeballing things. Or again, the size of the overall knob doesn't have to be that sort of like accurate. But let's go ahead and just sort of like try to get as close as we can. I'm going to call it 28 millimeters. So let's go ahead and call that dimension. Let's go ahead and call that dimension 28 millimeters. And again, the key dimension that we really want to worry about is going to be the size and geometry of this potentiometer. So let's get the overall diameter first. Right, probably 5.9 let's call it 6 for now. As I said, we'll probably go back and end up for adjusting for the tolerance later. But for now, let's go ahead and call this overall dimension 6 millimeters. We'll get the height so that we can figure out what the geometry or what the geometry is going to be for the overall space. All right. So let's call that height 4.75 millimeters, and that should be pretty good. The overall thickness, again, we'll probably just eyeball, let's call it, but just for thoroughness, let's call that 10 millimeters. We'll call the depth 10 millimeters. And then one last thing, actually, I forgot to do before, even in our initial sketch, is to lay out this little flange, right? So we actually have this little flange that we want to sort of deal with, right? The actual little flange that we want to deal with. I'm not going to worry. I'll probably just eyeball that too, right, for now, but it is a major component that we need to worry about. What we probably want to try to figure out how to design is actually, like I said, this overall knob is actually can actually spin farther to the right and to the left, right? And so we actually want to constrain how far it can go over. The overall, where that actual geometry is, I highly doubt it'll be just straight across. So I'm going to go ahead and try to estimate where that's going to, the rotation of that angle. So if I turn this all the way to the right, it looks like it is roughly perfectly horizontal, right? So let's say that that's all the way to the right. And if I spin it all the way to the left, it looks like it's roughly vertical, or sorry, horizontal. Did I say it? This right is vertical, and then left is horizontal. So if I'm just going to estimate, I suppose it's somewhere in the middle at about, let's say, about 45 degrees. Maybe that's the middle. But anyway, those are going to be the kind of things, the keys that we'll have to look at when we start to worry about that dimension. But like I said, part of the reason why this is going to be nice to do geometric or parametrically is because we can make those adjustments relatively quickly, send it off to the 3D printer, and then try again. But that should be about it. That should be everything that we need to be able to start doing our CAD model, which we will do in the next episode. So I will see you next time.